Hi everyone, this is Vara here. I'm going to do a lesson 11.4 using some new technology. So hopefully everything will work here. So 11.4 is called correlation. And it's a pretty good continuation of 11.3 where we talked about scatter plots. As a matter of fact, if you look right here, we start with a scatter plot. So our objectives are, you're finding, this is your new vocab word, the correlation coefficient, and we're going to call that the R, and you're going to hear me just talk about the R value. That is the correlation coefficient, and you can describe what it means. So remember, this is when you're looking at two variables. So correlation tells you the strength of a linear relationship, and we'll talk about that in relation to the pictures when we get down there. A linear relationship is strong if the points lie close to a straight line. So these are your points on your scatter plot. A linear relationship is weak if the points are widely dispersed, and that means spread out. So we say the relationship is strong if the points are close together and close to forming a line, and we say it's weak if they're dispersed. So this relationship here, your points are more spread out. You can see you have a positive relationship. It's going upward, but they're more spread out. Whereas this, your points are more close together. So you would say this is a stronger relationship and this is a weaker. So you can tell our eyes aren't the best judge of a linear relationship. This shows the same data, but it's on a different scale. So which set would appear to be more strongly correlated? Well, this one appears to be more strongly correlated, but it's at a different scale. So that's where the correlation coefficient, the R, comes into play, because it tells us numerically whether a relationship is strong or weak. So a number that indicates the correlation coefficient is a number that indicates both the strength and the direction. So it tells you whether you have a positive or negative relationship of a linear relationship between two variables. Facts/properties about correlation. Correlation requires both variables to be quantitative, which those are numbers. So remember when we talked about quantitative and qualitative, qualitative was categories, quantitative was numbers. The R value, or the correlation coefficient, is always a number between -1 and 1. If R is positive, there's a positive relationship among the variables. So I'm going to slide this up. So a positive relationship, remember, is just like a positive slope. If R is negative, there's a negative relationship among the variables. So that's like a negative slope. The R value will be exactly 1 or -1 if the points form a straight line. Okay, the closer R is to 0, the weaker the relationship. And we're going to look at some pictures of this on the next page, which help explain it more. And remember, all of these notes are also in the PowerPoint, which is on Google Classroom. And you can pause the video. Okay, here the pictures kind of tell the story. So we have, this would be, it's obviously a negative relationship. And notice how the points all line up to make a straight line. We would call this a perfect negative correlation, and the R value would be -1. This is strong, and it's obviously negative, so the R value would be a little bit lower. I'm going to say maybe -0.93. This would be a weak negative relationships. So let's say negative 0.6, and I'm just making these numbers up based on the picture. This is no correlation. This is an R value of 0. These relationships are all positive. This is a perfect positive correlation, so the R value is 1. This would be a little lower than 1 and even closer to 0. So as we're going in this direction, we're getting closer to 0, and as we're going in this direction, we're getting closer to 0. When we're at R and negative, or when we're at negative 1 and 1, we have perfectly straight lines, negative and positive relationship. And then as the relationships get weaker, we get closer to 0. When we're at 0, we say there's no correlation between the x and y. So an example of this would be like, you know, how old you are and how far your teacher runs every week. Absolutely no correlation at all. So let's look at some examples. It says select the most likely value of the correlation coefficient for each scatter plot. So I'm looking at this. It's pretty close. They're pretty spread apart. Like my first instinct was, ooh, maybe there's no correlation, but it's got a very slight negative correlation, but definitely not a strong one. So I would say negative 0.54. Remember, this number is not possible. It's only between 1 and negative 1, so that choice you could have eliminated right away. This is a good, strong, positive relationship. The dots are close together, and it's clearly a positive relationship. It's definitely not a 0. It's not perfect straight line. It's definitely not a negative. So it has to be 0.92. These dots have no clear negative or positive relationship, so this is an excellent example of a negative, or a R equals 0. Okay, so that's kind of pretty good examples of what they look like. And remember, downward slope or negative slopes always have negative R values, and the closer the dots are together, the closer you are to either positive 1 or negative 1. Okay, select the most likely R value for each pair of variables. So this is outside temperature and ice cream sales. So outside temperature is your X, so here's temp, and ice cream sales is your Y. Well, we all know when it gets warmer, we all go to Captain Sunday's more, so this is positive. So I'm going to say it's not going to be 0. It's probably not going to be perfectly 1. It's definitely not going to be negative, because as temperature increases, sales increases. So that's going to be 0.83. Number of miles a car has been driven and the price of the car when sold. So I'm going to say as miles on the car increase, the price of the car is going to decrease. So this is a negative relationship. There is going to be a correlation there, so it's not going to be 0. It's not going to be perfect, it's not going to be positive, so it has to be negative 0.7. The height of your classmates and your classmates' score on their last math test. I can tell you that there is no relationship between the height of students and how they score on their math tests, so that would be R equals 0. Okay, look at the data relating to sugar and calories of candy bars. We've looked at this data before. Put the data into L1 and L2 on your calculator and make a scatter plot and sketch it below. I think we've done the scatter plot before, but I'm going to let you put this in your calculator on your own, but I can tell you it looks something similar to that because I already put it in my calculator. So it says, based on looking at that scatter plot, will the value of R, the correlation coefficient, be positive or negative? It's going to be positive, which we talked about before. We said that as the sugar content goes up, the calories also increase. So that's a positive relationship. Why does this make sense? Because candy with more sugar will probably have more calories. And I'll let you fill that in yourself. I would say an R value for this, it's going to be positive. It's definitely not R equals 1 because they're not in a straight line. So this is an estimate, and I'm going to estimate it at about 0.87. Okay? All right, now what we want to do last of all is show you how we have our calculator find the R value for us so that we're not just looking at the scatter plot and guessing. So I'm hoping this shows up okay. Now what you're going to want to do is pause the video and put this data into your columns like I have done here into L1 and L2. And then I'll just walk through these steps here that are in your notes and show you on the calculator. So first I have my data already input there, and your notes say first the diagnostics must be on. So it says I want to press second 0, and this is going to bring up the catalog. And I want to scroll all the way down till I get to diagnostics on, and it's in alphabetical order. So there we go, diagnostics on. And when I get to that, yeah, that shows up pretty good. I want to hit enter. I'm going to turn my light off. I think that works better. Enter, and then enter again to make sure my diagnostics are on, and it says done. Now to find the R value, I want to press stats, and then I want to go over to calculate, which we've done before, only this time I want to choose menu item 4, which is linear regression. See, it says AX plus B. That's like MX plus B from point slope form. So I want to go down to 4 and hit enter. Remember, you can just press the number 4. And then this is where you tell the calculator the lists you want it to look at. So on mine are list 2 and list 3. On yours, you'll probably want them to be list 1 and list 2. And so those are what I want. I also want to make sure up here that it says linear regression, AX plus B. And then I can just hit all my enters. And then there's my R value right there. We don't want the R squared, we want the R value. So for this problem, my R value, and remember correlation coefficient is the R value. So my R value is going to be R, and I'm always going to say approximate because we're rounding it a little bit, positive 0.944. So that is a pretty strong positive relationship between weight and waist size for these people. So what does the value of the R tell you about the relationship between weight and weight size for the students? There is a strong, because I have an R value, a high R value, strong positive relationship between weight and weight size. Weight and waist size. Weight and waist size. Okay, that is it for 11.4.